Suppose you have two boxes, box A and box B. Each box contains 4 cupcakes. Box A has 3 chocolate cupcakes and 1 vanilla cupcake, and box B has 2 chocolate cupcakes and 2 vanilla. Now we play a game. First, you choose one of the boxes at random, and then you randomly choose one of the cupcakes inside. It happens to be a vanilla cupcake, so you eat it. And then you go back into the same box and randomly choose another cupcake inside. Here's the question. What is the probability that this second cupcake is also vanilla? Give this problem a try if you want, but be careful. Alright, so it's a pretty simple problem. We've got two boxes, A and B. A has 3 chocolate cupcakes plus 1 vanilla cupcake. B has 2 chocolate and 2 vanilla. So, first we choose a box at random. Well, that's just 50-50. Probability of choosing either box A or box B is 1/2. Okay. And then we take out a random cupcake from the chosen box. And it happens to be vanilla. Alright, so if we choose box A has only 1 vanilla cupcake in it, so we take it out and eat it. Then there's only 3 chocolate ones left, and the second cupcake we choose has to be one of those chocolate ones. So if we choose box A, the probability of choosing a second vanilla cupcake is 0. Well, yeah, no vanilla. Okay, but what if we had chosen box B instead? Well, if it was box B, then we randomly take out the first cupcake, and it happens to be vanilla. And we eat it, so now there's 2 chocolate and only 1 vanilla cupcake left inside. So when we take out the second cupcake, it has a 1 in 3 probability of being vanilla. Yeah, okay. And finally, we put it all together. So first, we randomly choose between box A or box B, both with a 1 in 2 probability. If we choose box A, there's a 0% chance of the second cupcake being vanilla, and if we pick box B, there's a 1 in 3 chance. So 1 in 2 times 0 plus 1 in 2 times 1/3 equals 1/6. There we go. 1 in 6 chance of choosing a second vanilla cupcake. Cool. 1 in 6 probability of choosing a second vanilla. And then naturally we go and do what any good normal person does. We grab a couple of boxes and a bunch of chocolate and vanilla cupcakes. We put 3 chocolate cupcakes and 1 vanilla in one box. And then we put 2 choc and 2 vanilla in the other box. And then we start playing this little game. Choose a random box, then choose a random cupcake, then choose another one, and we keep track of how many times we choose a second vanilla cupcake after choosing the first vanilla cupcake. And we repeat this again and again and again and again and again. I don't know, say 25,000 times. Yeah, 25,000 sounds like a reasonable sample. And when we're done, we find that out of 25,000 games, we ended up getting 9,431, where the first cupcake was vanilla. And of those 9,431 games, we got 2,064, where we chose a second vanilla cupcake as well. So, 2,064 divided by 9,431 equals 0.218. 0.218? Hey, wait, that's not 1 in 6. 1/6 is about 0.166. 0.218? That's not really close, to be honest. I think we better redo the 25,000 games again. Do it all over again, do it all again, and this time we get 9,339 games where the first cupcake was vanilla. Okay, and 2,147 of those where the second cupcake was vanilla as well. 2,147 divided by 9,339 equals 0.229. 0.229? It went up! It went up! Why is it not working? Ridiculous. It should be 0.166. Math is broken. 1 equals 2. Reality begins to break down and the universe explodes. Or does it? Let's take a closer look at these numbers, shall we? 25,000 games. Out of those 25,000 games, there were 9,339 when we chose the first vanilla cupcake. And out of those 9,339 games, 2,147 when the second one was vanilla as well. Okay, now let's see which of those games were when box A was chosen, and which ones were when box B was chosen. So for the 25,000 games, 12,417 of them we chose box A, and 12,583 when we chose box B. Makes sense. 50-50, right? But then what's this? Out of the 9,339 games, 3,078 were with box A, and 6,315 were with box B. Huh? That's not 50-50. What's going on here? Time to think. So, both box A and box B contain 4 cupcakes, but box A has 3 chocolate and 1 vanilla, whereas box B has 2 chocolate and 2 vanilla. So yeah, in those 25,000 total games, we'll be choosing both of them half the time. But if we pick out the first vanilla cupcake, then of course it's more likely to come from box B than from box A, because there's 2 vanilla cupcakes in box B, but there's only 1 vanilla cupcake in box A. Ah, I get it now. Stupid maths. Yeah, so when we choose the first vanilla cupcake, it's going to be from box B twice as often as box A, right? So that's a 1 in 3 probability for box A and a 2 in 3 probability for box B. Not 50-50. Oh man, I hate probability. Okay, so we gotta redo everything again. So first we choose a random box, either box A or box B, but it's not 50-50. Why? Because then we randomly choose a cupcake from the box and it happens to be vanilla. That fact, the fact that it happens to be vanilla, means the probability that we chose box A is 1 in 3, and the probability we choose box B is 2 in 3. Not 50-50. Okay, yes. And then we choose the first cupcake, which happens to be vanilla. So box A now has 3 chocolate and no vanilla, so it's impossible to choose a second vanilla from box A. That probability is 0. And box B now has 2 chocolate and 1 vanilla, so a 1 in 3 probability of choosing the second vanilla. Yeah, 1 in 3. Okay, and we're almost there now. So the total probability of choosing a second vanilla cupcake, given the first one being vanilla, is going to be 1 in 3 times 0 plus 2 in 3 times 1 in 3. The 1 in 3 times 0, that comes from us choosing box A 1/3 of the time, and never being able to choose a second vanilla cupcake. And the 2 in 3 times 1 in 3, that's from us choosing box B 2/3 of the time, and choosing the second vanilla cupcake 1/3 of the time. Yeah. And so the real answer is 2 out of 3 times 1/3, which equals 2/9. 2 out of 9 chance of choosing a second vanilla cupcake given the first one was vanilla. Not 1 in 6. Ah, well that explains it. Okay then. Just another boring day saving the universe. Please subscribe to my channel. Bye.